Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hey guys, welcome to a brand new episode of the Clear to Send podcast. This is your host, Francois, and I'm here with Roel. Hey Roel, how are you?
Hey, good morning. How are you?
Good. I feel like a real radio host because I'm standing up recording this episode.
Yeah, you've been working on your new office. You've been sharing some photos with us in the Slack group, and it looks very impressive. Great job on renovating your office.
Yeah, thank you. It took me a long time, but yeah, I'm happy with the results, and I got myself a fancy standing desk, so it's actually pretty cool.
Awesome. I mean, I'm kind of jealous. I'm sitting right now. I don't have a stand-up. I guess I could stand up if I want to, but I'd have to reach down for my laptop. So first world problems for me.
Exactly. And I'm happy right now, but we'll see in half an hour. All right, so today we're together to talk about 802.11k. So we did a couple of weeks back, we did an episode on 11R, and then we told you guys we'll follow up with 11k, maybe V. So here we're back and to talk a little bit more about 11k, talk about the theory behind it, talk about the practice a little bit. But right before that, we have a couple of news items for you guys.
Yeah.
And also something I wanted to mention that was weird to me is I started to listen to podcasts in 1.2 speed on Spotify, and I listened to our podcasts in 1.2 speed.
And how does that work out since there's two different voices there?
Yeah, it's not, and plus my accent, so it's not as easy to understand. But
I know I listened to Audible at various speeds depending on the who's doing the audio, but a lot of times the guys the books that I've been reading, they speak very slowly, so I could change it to about 2 times speed and still understand what they're saying. Yeah, that's how slow some of these guys are in the books, but good for me since I could finish a book much more faster and get started on other books.
Yeah, Audible, I can do 1.5 usually. Podcast depends on the host.
Yeah, exactly. So too bad, guys. You can't listen to us at faster speeds since we both speak at different speeds and Francois has an accent.
Yeah, I tried the Wi-Fi Ninjas at 1.2. It was perfect. Okay, but I guess hearing our own voice at a faster speed is kind of weird.
Yeah, I'll have to try that out.
Yeah, you have to try that. All right, let's talk about the news. First news out is a new generation CBR standard.
Yeah. This is brought by the Wireless Innovation Forum.
Yeah, so they announced that, and then we have the link. You'll be able to look at it on the Business Wire website. So it looks like we're getting some sort of standard for CBRs.
Yeah, and I think we'll see, a big use out of this. I find that this is a lot more structured and a lot more informational than, say, the generic term of 5G, because here you can actually get actual documents, right? So if you go to the article, it talks about how they've added some optional features which would expand or the growth of CBRS. But at the very bottom, you can actually download some of these documents. And I think that's where a lot of the meat is if you look at the documents and the enhancements, you'll start to learn about how CBRS works and how it will affect what we do day to day, right? So you can see the functions of it, looking at the first release, and then you can look at the second release. Release is what they just put out there.
And it's I like it because it's not like those very dry documents that sometimes we get from the the IEEE, the standards. It's like actual slideshows that you can look at, and they have diagrams. Makes it a little easier for us to understand.
Yeah, they've organized it a lot more efficiently, and they tell you what's deprecated, what they've added. So I think it's a well-made document, and it's worth looking at.
All right, so we put the link in the description so you guys can take a look at that. Second news item, I guess, is we get some stats from Cisco Live Europe last week. As always, Jason Davis, who is like running the NOC, likes to share some stats on Twitter, which is awesome. And he shares some stats on the wireless clients capabilities or distribution, and we can actually see that most of the Wi-Fi clients devices connecting to the Cisco Live Wi-Fi network were AC devices, like 85% of them. And we can see 6% of Wi-Fi 6 devices, and then 4% of 11N and 4% of 11N 2.4.
And it's interesting because of this, how it was looking at last year at Cisco Live with AX just coming around, right? And then now I think it's a big uptick from the previous Cisco Live, because now it's going to overtake 11N pretty soon.
Yeah, I was a little disappointed in the Wi-Fi 6 numbers, like 6% of Wi-Fi 6 devices. I was expecting, I guess, a little bit more.
A much larger number.
Yeah, because I mean it's been out like for a year now. You can buy client devices for a year now. So I was just expecting people to have more, Galaxy S10s and iPhone 11s.
Yeah, I probably would have wanted to see a bit more of those numbers, but maybe when Cisco Live US comes around, we may see a larger uptick. I don't know. Maybe in Europe there isn't such a big adoption for Wi-Fi 6 yet. Who knows? Or maybe we're going to see a slower adoption rate for Wi-Fi 6. But I guess also what I wanted to know was the type of clients that we're connecting in. And I'm not sure if they're able to grab those kinds of statistics, but are these mostly, for example, the Wi-Fi 6 devices, are those mostly mobile phones, or are we seeing, how many of these are we seeing are laptops, for example?
Yes, you're right. Yes, that would be interesting information to have, since we see more and more laptops. I was teaching last week in Belgium. I believe one of my students had a Wi-Fi 6 card in his laptop. So I guess we're seeing more and more Wi-Fi 6 enabled devices, and I guess it will be interesting to get the stats from Cisco Live in the US in a couple of months.
Yeah,
and try to compare, how how fast we're adopting Wi-Fi 6 standards.
Yeah, and the other thing I wasn't sure of was when this capture was made, because it mentions about 10,885 total clients. So I wasn't sure if this was captured early on in the event, and maybe it was in the morning before everybody was in the venue. And also Cisco Live Europe, I guess, has less attendees than the US. So we may see some variation there. So I guess that we'll look forward to seeing these same statistics at the other Cisco Lives.
Yeah, and thank you, Jason, for sharing all those data. I just love it every time I see it. So please keep doing it for the upcoming Cisco Lives. It's awesome. All right, so next item for the news is the Ekahau. They're actually about to launch a new tool. And they put it out on Twitter that they have their launching event, which is a webinar on next Thursday on February 6th. So I guess this coming Thursday. And we put the link so you can register and attend this event. It's going to be hosted by Tony, which is the new Director of Product Marketing. Congrats, Tony, on the new job. And then Stu, which is going to be, he's a sales engineer. And I guess he's going to be talking on the new solution. They also have Ansi, which is the Vice President of Product Manager, and they have Miko, which is the Senior Director of Product Manager. So typical Ekahau launch. And we'll see. They said they have a new tool to win the war against bad Wi-Fi networks. Yeah,
I mean, you can kind of get a sense for what that might be looking at the graphic that they include on that Twitter announcement. But I also saw something posted during Cisco Live Europe
Yeah.
which it was Ekahau showing something. So I'm guessing that's what it is. But I
Yeah.
don't want to spill the beans before the announcement.
Yeah, well, you see on the picture, you see someone with a sidekick and then a cable connected to something that looks like a phone.
Yeah.
And then it looks like he's shooting at some microwaves and evil devices.
Yeah, it looks like a Bluetooth headset, a microwave, and I don't know what that third one is.
Looks like a jam or something.
Yeah, it kind of looks like it, but that'll give you an idea.
Yeah. All right. Next item on the news is the Wi-Fi Alliance. They have their newsletter, the Beacons. Awesome name, I guess, for a newsletter about Wi-Fi. And then they came out last week with the 8 Wi-Fi trends expected for 2020. And if you look at it, it's interesting. Obviously, you have Wi-Fi 6, Wi-Fi 6E in 6 gigahertz, probably in the US only in 2020. Then they're talking about WPA3. And then if you go all the way down, they talk about Wi-Fi aware to power drones in the sky, which was the most interesting trend, I guess. I don't know.
I wonder how that is going to be. I'm just curious, like how that's going to be used as, I guess, a Wi-Fi Alliance certification.
Yeah.
I'll have to look into that. But I do want to say something that relates to this with drones, right? So one of the, as people are aware of the coronavirus, that's, I guess, a worldwide emergency. What they've been doing in China is using drones to contact people that are out and about in the city. And they use a speaker to talk to them and telling them to like asking them why they're out and walking. And especially if they don't have a mask on.
Wow.
And I saw a video of that and I thought, oh, that's kind of interesting that somebody's remotely driving a drone. They're not out there physically, but they're using the drones to communicate. So I don't know, maybe that's part of this certification for like this proximity-based discovery kind of thing.
China is next level on technology also. So they built a 57-story hospital in 19 days.
Is it already finished?
Yeah, I saw it on a video somewhere.
Yeah.
It's crazy.
Yeah, I saw a video of them building the foundation stuff. So for them to build something that quickly is crazy.
Yeah.
Can you imagine having to build the wireless network for that hospital in just a matter of days? All new greenfield.
Oh my. I guess
it'd be a lot easier than
good. Yeah.
It'd be easier than doing a migration.
Yeah. Oh my! And going back to the drones, so in the in the Beacon article, they talk about the fact that companies like DJI are actually trying to incorporate that into their drones. So they actually over Wi-Fi they communicate. It's like a machine to machine, from what I understood, communication. So drones talk to each other, so they don't bump into each other. They have that proximity based.
Yeah, okay, that makes a lot of sense.
Yeah.
So a lot of those, you'll see like performance drones. Well, instead of fireworks, they do all these cool visualizations in the sky. Okay.
So we'll see how how it goes. I think those trends are pretty futuristic.
Yeah, for sure.
But it's nice to see that the Wi-Fi Alliance is actually looking at those things. They also talk about Passpoint. Expanded Passpoint. So, WPA3, the Wi-Fi 6, they're obviously thinking about the future, which is nice. I just don't know how much marketing that thing is. So, I guess we'll see in the real life.
Okay.
And then another item for the week is they actually have a wireless conference focused on port networks in London. Upcoming. So I've been contacted by the organizer. It's going to be on April 1st in London, UK. And so if you do a lot of Wi-Fi in ports, I guess this will be the place to be and exchange with your peers. It looks pretty cool, actually.
It's very specific, and by ports, you mean where ships come and dock, and then there's cranes that take inventory or put inventory on ships. So it is a very specific conference, and I guess it addresses. It shows what needs there are at these ports regarding wireless. So that's kind of interesting to me to see what would come out of that, especially the conference itself, and who's going to be there. What are they going to talk about? Have they mentioned what some of the talks will be?
No, they have the program on the website, but for now. It's you can request a copy of the program.
I see. You just gotta give your email.
Yeah. So exactly. You have to put your email. Right. I'm guessing. So from what I've seen, so port is also a lot of container yard and maybe remote communication with ships. So sometimes it's not only Wi-Fi, right? When we talk about wireless communications in those environments, sometimes it's private LTE. Or sometimes it's LTE altogether. So I think it will be not only about Wi-Fi, but they'll talk a lot about the problematic that they have, I guess, in those environments. Mm-hmm. Very interesting. If I could go, like if I was living in London, the real one,
I
would probably go just out of curiosity, right?
Yeah, it would be really interesting to see, especially the very specific use cases they have and the challenges they run into.
Yeah. And I had a couple of, students talking about, deploying Wi-Fi in container yards or in ships, not the cruise ship, but the actual ships that they use to do some actual work. And it's super hard to design Wi-Fi for those environments. It's like steel, steel boxes and steel boxes.
Yeah, exactly.
Yeah, so they do a lot of AP on the stick, and then after that, like how do you carry the communication on the container yard where when the containers always change positions, you don't have a lot of mounting options, a whole bunch of problematic that you don't have in a typical office environment.
Yeah, it's not anywhere near the same, but yeah, I agree.
All right, and then last item for the news this week. So Roel, you've been busy this week thinking about the future of CWNP, right?
Yeah, so I spent last week over with CWNP and a lot of different people, and this is called the job task analysis, where we update objectives for certification. And so specifically, this one included CWNA. So we'll see an update to that. And then also I was part of the job task analysis in creating a new certification, which is the professional level, a professional level certification to the CWSA. And so we tried to determine what those objectives are and the different tasks that this person would do. And I will say it is not an easy process. So there's a lot of work that has to be done, a lot of brainstorming. There'll be debates back and forth. So it's not very easy to come up with objectives, and it's how you generate what will be in the exam. And so trying to create something in that's a very specific format, it lends to, it becomes very difficult to try to maintain what you keep in the objectives, right? So looking forward to when CWNP releases that information, and hopefully we can bring Tom Carpenter on the show to talk more specifically about the process, because what he mentioned during the job task analysis I thought was really good information and knowledgeable, even for those who are exam takers in learning how to read the objectives.
Awesome. I just took an exam this week, so maybe it can help me as well.
Yeah, for sure.
All right. So that's it for the news for this week. All right, so let's talk about the main subject for the week, which is 802.11k or radio resource measurements, RM, right? So it makes it even more confusing.
Yeah, not to be confused with the other RRM.
Yeah, exactly. This is the radio resource measurements coming right from the standards, right? So that's a standard term for 11k. If you want to find the actual section in the standards related to 11K, it's clause 11.11 in the latest 802.11 2016 standards.
Awesome. Yeah, and 802.11K, as you'll go into it, I think it's a good partner to 802.11R, and you'll see why as we go into what 11K actually is.
Yeah, so 11K, it's various types of measurements that are defined and enables the client stations to request measurement from other stations, or most commonly from the access points or the controller, and then those information can be used to optimize the radio communications, and then so we'll talk about more in the specificity of those informations, and for example, 802.11k stations are able to assess how occupied or idle the frequency channel is, and then they can also report that information back to the AP. So the AP has that client knowledge as well. And then the 11k, if you look at the standards documentation, the 11k section actually details which data can be, which statistic can be gathered by clients and AP, and then how those exchange happens between the client and the station. All the mechanisms are defined in the standard. It's very detailed. They even tell you, how to calculate, the noise floor environment, how a client station should calculate all these parameters, and then how they should send it back to the AP.
Yeah, it's a really interesting amendment to the standard because it's supposed to help a client be more have a better understanding of the environment around itself, right? So if every client supported 802.11k, we would have better roaming capabilities. We'd have better increased efficiency in how all these stations in the same location can interact with the wireless network. But of course, we have problems where not all clients support 802.11k.
Yeah, so why did we wanted to talk about 11K? First of all, it can help, like you said, the client devices to take better decisions, right? Especially when it comes to roaming. So when the client devices has more knowledge about the RF environment, about the APs around himself, about how busy the channels are, he can take better roaming decisions and actually roam to a better channel faster. And this is, I guess, the main application of 11K in the real world, and that's why it's really, it's usually coupled with 11R, which is fast roaming, and that's really the benefits of 11K in the real world. Second reason why we wanted to talk about it is it's not always supported on client devices.
Yeah.
So it's not something that you'll be able to leverage all the time. You might be able to leverage it for a subsection of your client devices, but not for everyone. I think it's getting better and better. We see more and more support for 11K, especially on mobile devices, phone, tablets, and so on. And then the third points that we wanted to outline is more related to the practice. In practice, you'll see that some client devices will advertise the fact that they support 11K, but they don't, or sometimes they advertise that they don't, but they do. So you really have to test it out in a lab, do some packet capture, and find out, how the client is operating, right?
Yeah.
If you only look at what the client is advertising, it's kind of like listening someone bragging about something, but it's actually not doing anything, right? You're just talking,
or it's holding back. It's And you have some screenshots of this, which we'll include in the show notes over at cleartosend.net/206, because it's interesting that it wouldn't advertise that it supports 11K, but in reality, it could. And where I have problems with this is sometimes if clients don't support 11K, then they have problems associating to the SSID that supports it. And it could be that it doesn't like the information elements, and so it just decides not to join. And so we run into problems that way, right? And so there's different ways to mitigate that, where a lot of times we just disable 11K because we want that backwards compatibility.
Exactly. So in order to find out what's actually happening, you really have to do packet capture. We have a couple of examples. We included some filters that you can use in Wireshark, in the show notes of the episode, and then we also have a couple of nice resources of people that also analyze 11K frames.
This will be nice if you're going to be studying for the CWAP and learning how to analyze 11K frames and the support and what to exactly look for after you've got that capture and you're looking at it in Wireshark. So we'll include those filters for you, and you could take a look at it yourself in your own networks.
All right. So what is really happening with 11K? Like what information is exchanged? What type of mechanism are in place for that to work? So most of the time, the APs gather client radio information via specific mechanisms. So the AP will request some information, the client will send it back, and then based on that information, the AP might take some decisions. And the clients can also request information from the AP. So it could be, can you please send me a list of, the neighbors' APs, because I need to roam and I need to take the best decision. So they will request what we call a neighbor AP list.
Report.
AP report, thank you. And then it will, based on the result of that report, the clients can take a better decision. So it works in both directions. So everyone can get a better feel of what the RF environment looks like from the AP and then from the client perspective.
Yeah, I think you'll really hear us talk about the neighbor reports more than anything else, because right now that's what seems to be the most popular use of 11K, as it enhances the way we use 11R. So if we go back and we'll include a link to our 11R episode, because that's where we really talked about fast BSS transition, right? So that's episode number 198. And in fast BSS transition, that's where you're just trying to speed up the roaming reassociation to another AP. But a lot of times, if you're roaming to another AP, what that includes is trying to do a probe request, right, to join another AP. And then what happens is an AP will respond. So this is before you even know what APs are around you. Yeah. And so 11K would help speed that roaming process as we talk about the information that's gathered from APs.
Exactly. Based on the report, the neighbor report responses, the client devices will already know on which channels it has potential candidates, right? So instead of sending probe requests to every channel supported by the client device, which can be a lot, if you count all the 2.4 and 5 gig channels, it would only send those probe requests on the channels that it got from the neighbor report responses. So it actually optimizes, the probing section and speed it up quite a bit.
Yeah, so you could shave off milliseconds from that roam, and having your client know exactly which AP to roam to would make a better performing wireless network.
Yeah, and also because you don't have those clients sending all these probes requested on all these channels, you're also saving a lot of airtime for actual, useful communications on those adjacent channels. Okay, so what type of information are we talking about when you talk about, information exchange, radio information exchange between the client and the AP. So the first one is, the neighbor reports, the one we've talked about. So the client device can request a neighbor report. So it will send a frame that we'll talk about later on in this episode. Send a frame to the AP requesting, the neighbor report for a specific SSID. It's usually the SSID it's currently associated to. And then, the AP will respond with a list of, potential candidates for the next AP to connect. And then in the report responses, the clients can learn valuable information. We talked about the channel the AP is on and so on. And all that information can be carried over to the client. So the client can take that in to take a better roaming decision.
Yeah.
So that's a main one.
That's the big one.
That's a big one. The second one is the client statistics. So SNR, RSSI, data rates, frame transmission, frame retries, frame errors, all of that can also be communicated back to the AP and the controller. So that would be nice information to have for the controller. Then you have channel statistics. So the client devices might actually gather noise floors and information and calculate the channel load, and then send that back to the AP. And then the AP can, decide to do whatever they want to do with it. And then the last piece of information is the transmit power control, TPC, that can be used to reduce interferences in both frequency band, the 5 gigahertz and the 2.4. If it's too noisy, maybe they can reduce the transmit power and so on, and make sure that both the clients and the AP can still operate at the lower power.
Yeah, so we have different reports here, or different methods of using radio measurement. And some of these are created by the client itself. And so you can kind of see why there are devices that don't implement some of these features, right? And maybe neighbor reports would be the one thing that they actually utilize the most. But when you're when you're doing client statistics, for example, that's taking power away from the device, because now it's got to do all this other work, right?
Yeah.
And so if you've got a mobile device, say maybe a handheld scanner, it could drain the battery as it's trying to determine SNR, RSSI, and then send that back. So,
yeah. And if you look at the standards, they actually specify, like the noise floor environment. They specify how the client should calculate that. They specify for how long they should calculate it. And everything is very, detailed and specified. But yeah, you're right. It's going to take some time for the clients to do it, and some resources that, maybe the device manufacturer wants to save battery life, or, to do more important things.
Yeah, and then this is where I start to start questioning how well the drivers are, right? How is this implemented on the device, and is it done efficiently? Is it done properly? Those kinds of things.
And then when you actually look at the standards specification, you understand that it actually takes some effort to develop in the Wi-Fi driver, because it's a lot of things, right? So you understand that some devices might not have it available, right? Some cheap IoT devices might not have that available.
Yeah, exactly. You're going to have a good chip in there to do this type of work.
Yeah. And at the same time, it's only useful if you do a lot of roaming, right? So if you develop a Wi-Fi device that, is intended to be used in a stationary environment, you don't really necessarily need 11K, right? Why would you spend the money to develop those features when you know that the device will just stay at the same location all the time?
Yeah.
So you don't want the device to roam, right? So it's, all of that, and that, happens in the real life.
Mm-hmm.
All right, so that's the main things, the main type of radio information exchange between the AP and the client devices. And then something we didn't mention, but depending on how the APs or controllers are configured, the controllers might be able to use those information from the clients to take some important radio decisions. Maybe you have on a Cisco controller, maybe you have ORM enabled, and maybe ORM will take those information in and decide to change the channel on an AP or change the transmit power and so on. So those information could also, go back and feed the radio resource management systems on the controller.
Yeah, I see a lot of excuse me. I see a lot of potential for using 11K. We just don't see it used often on our network with the client devices. And I think if clients did support this more, we would have better performing wireless networks because we are able to provide neighbor reports. I mean, there's a lot more roaming going on, I think, especially in my environments, a lot more roaming going on in my networks than what we've seen in the past, right? Especially when there's a scenario I was troubleshooting not too long ago where in a warehouse, these devices weren't roaming properly, but it didn't seem like so they were using a device that wasn't very good with the Wi-Fi driver. It didn't really support a lot of these extra amendments here. And so the roaming process was just inefficient. And I think if we had these neighbor reports, at least in the device, it would have made better decisions in selecting the AP it was supposed to roam to, or it could roam to, and make the process faster. Because what I would see is people moving with a device to one AP, but then they would quickly go back to the previous AP as an example, right?
Yeah, I think it will get better and better. I believe the neighbor report capability is mandatory for Wi-Fi 6. So we have to check. I know that with my Wi-Fi 6 device, it's there. So we'll have to see. But if we start to see it in every new device that comes up on the market, that would be really good for us.
Yeah, it's going to take a lot of time because since there's a lot of environments where they're using very old devices that probably don't even support 11R.
Yeah, so good transition. How do you find out if a client device supports 11K?
You're gonna have to do some analysis.
Yeah,
if you don't see it in the data sheet, or you don't see it as in the Wi-Fi Alliance product finder, where you can try to search for some of those capabilities, you might not see it. So you're gonna have to do some analysis where you capture frames.
Yeah, so usually when we try to analyze any sort of client devices capabilities, we look at the association request, right? So you want to be able to capture that association request. The only challenge you might have is if the access point you're using to connect doesn't support 11K, the client might not advertise the fact that it also supports 11K, right? So what you could do instead is you could use a tool that will generate a fake SSID that supports everything, including 11K. And then when the client's device associates to that fake SSID, you capture the association request and you find out the maximum capabilities of that device. And this is exactly what the profiler tool on the WLAN Pi does. So if you've never heard about that, it's actually a pretty nice tool to find out Wi-Fi client devices capabilities. You can go to the WLAN .com website and then find out from the GitHub documentation, the profiler documentations, and the profiler will just generate a random SSID that supports everything. And then you connect to that SSID. It doesn't do anything because it doesn't process any connections, but it will capture that association request from the client device and then spit out a list of capabilities. You'll be able to see if it's 11K compatible, and it also saves the association request as a PCAP file, so you can download it and analyze it on Wireshark on your laptop afterwards. Yeah. So it's a very nice tool to use to find out, if a client is 11K compatible. And then once you capture that association request, you actually have to drill down and look for the RM enabled capabilities information element, right? Mm-hmm. And then in this, if you have the RM enabled capabilities information element, it means it's 11K compatible. And then if you drill down, you can actually see what is exactly supported. The one we usually look at is the neighbor report enable bit, which is in the first section of the RM capabilities. And then you can try to see if it's set to 1 if it's enabled and 0 if it's not enabled.
Yeah, and you had an interesting case in your lab, Francois, with your device as you're trying to see if your device supports the neighbor report.
Yeah. So in my lab, what was interesting is when I looked at the access point first, I tried to see if it supports 11K. So on the access point side of things, you have to look at the beacon frame. So the beacon frame for the specific SSID I use. And then in that beacon frames, you look for the same RM enable capabilities information element. I found it. And then in this beacon frame and under the RM enable capabilities, I can see that the neighbor report is enabled. Okay. So I was like, okay, cool. I know that my access point supports 11K and I know that the neighbor report capabilities is enabled. Let me just connect my device and look at the association request. I did that. And then what was interesting is I saw the RM enable capabilities information element. So I know my device is 11K capable, but then I saw that the neighbor report was disabled. So I was like, okay. And then I start to look at the different frames that my phone exchanged right after being connected to the SSID, and I see a neighbor report request. So what's weird is my device is advertising that it doesn't support the neighbor report, but right after that, it just sends a neighbor report request.
Yeah, and so this is under the category of RM or radio measurement, and then it's an action code of neighbor report request.
Yeah, it's an action frame. It's a management frame. It's an action frame. Yeah, and the so going back to why do we want to talk about 11K in this episode today is sometimes the client devices will advertise something in the association request the association request, but sometimes it will operate differently when you actually look at what's happening once the device is connected. So here, it's pretty much the device is telling us, I don't support neighbor reports, but as soon as it connects to the Wi-Fi, it sends a neighbor report request. So it actually supports it. It just lies about it.
It didn't advertise it. And what kind of device were you using, Francois?
It's the Galaxy S10.
Okay.
I believe iOS, I don't know, maybe you can try with the iOS device, but I think iOS is pretty much the same
iOS
thing.
Supports it.
Yeah. It supports it, but I'm not sure they advertise the...
Yeah.
So
after this, I'll generate my frames to, and we'll include that in the show notes so we can do a comparison and you can see if maybe iOS does the same thing or maybe it actually advertises it. So we'll take a look and compare.
And sometimes it's the other way around. They will tell you that it's supported, but they actually don't do anything about it.
And that's an implementation problem of the driver itself.
Yeah, and if you never check in the packet capture, you'll never know.
Yeah, so that could be like you putting in a feature request or fixing a bug. I would classify that as a bug if it supports it, but it's not actually doing a request.
Yeah, implementation issue.
Yeah, where you think, well, because it says it supports 11K, and so you assume, all right, I'm enabling 11R and K, and my roaming will be way better, right?
I guess it's better the other way around when they tell you they don't do it and they actually do it. Yeah. Anyway, so looking at the frames are, really going to tell you what's going on. We usually say packet never lies. So I guess in this case, sometimes they do.
In this case, it lied to you first, and then it did.
Yeah, and then I told the truth. Yeah, you'll see in the show notes we included a couple of Wireshark filters, so you can actually filter all these, radio resources, radio resource
Radio
measurement frames. Yes. So you'll be able to see the neighbor requests, the neighbor responses. And if we talk about the neighbor request first, the neighbor request, what's really important for the clients to do is to specify which SSID it's associated to, right?
Yeah.
So the client will just send a request to the AP and say, please tell me, the neighbors for that specific SSID, and then the AP will look at the other APs, in the environment, and then respond with, I have AP A on channel 36. You might get a good connection from him. I get AP C on channels 149, and so on. And it will send all that report information back to the client devices.
Yeah, and you might be thinking why it would include the SSID, right? Well, an AP can be broadcasting multiple SSIDs, and so you want to know which APs are actually broadcasting that SSID. And I do run into environments where some APs are not broadcasting a specific SSID for policy reasons, or maybe there's a reason why an SSID shouldn't be in a specific environment. So that's why in the parameters there, it'll say, I am doing a neighbor report request. I'm specifying this for this SSID. Tell me all the APs around me that that are broadcasting that SSID.
And it's also important because some APs won't respond if you don't specify the SSID. So I'll just, okay, I got the report, but you didn't specify the SSID. So, I'm answering with an empty response pretty much. So yeah, it works better, I think, if you specify the SSID. But obviously you don't control that, right? The client device is supposed to know all of that based on their Wi-Fi driver implementation.
Yeah, we're still at the mercy of the device supporting different capabilities and then how they implement it. And as in your case, Francois, it shows that initially it didn't seem like it supported the neighbor request there, but it in fact did request for a neighbor report. And we'll see how my iOS device actually implements 802.11k. I think I will be using the same AP as you, so it will at least have the same capability from the AP and same function from the AP. We're just going to test out a different device.
Yeah, and then in my case, because I only had one AP here connected, when the AP sent the report responses, the neighbor report responses, I didn't have any neighbors because I only have one AP. So it made sense, right? But if you're in an environment, the enterprise environment, not at your home lab, you might see a whole bunch of different candidates in the actual report responses.
Yeah, so we'll try to include a frame capture that has neighbors in it. I have 2 missed APs, so I'll see if I can get that other second missed AP running and generating a list there.
Awesome. Right, I think that's pretty much it. We'll put all the the diagrams and the picture in the show notes so you guys can take a look at it. I also came across a really nice YouTube video from Mark Williams where he explains the neighbor reports in details on his Cisco controller. I found it really good. It's like 20 minutes, but he goes deep into the packets and how he configured everything on the Cisco controller. So we'll just link that as well as a resource in the show notes so you guys can take a look at it.
Awesome. Well, Francois, what are you up to this week?
I was actually supposed to do some validation work for a customer. They pushed back 1 week, so I actually have some time on my end. So we'll see. I'm staying home with the family, probably work on a couple of stuff on my side. I wanted to work on a couple of blog articles and stuff like that. So we'll see.
Some catch up.
And also I want to prepare myself for the validation work. I actually have some stuff I want to automate as much as possible. So I'm brainstorming. I've been brainstorming some stuff I could do better because I'm actually going to be validating a lot of APs.
Okay.
So I actually worked on the script last week where it takes the pictures from Ecal project files and save them with the name of the AP and then put them in a different directory, because I used to do that work manually, but it's very time consuming because you have to click on the AP object and then go to the notes, save the picture on your desktop and then rename it afterwards. So I have that automated, so which is nice. But I also want to rework on my report templates.
Yeah. You work a lot with reports, so I can see why you'd want to try to automate some of that work or try to make your reports a little more efficient and fine tuned towards your needs, right? So maybe we can talk about that in a future episode about how we could leverage what we gather from Ekahau into something different, right? And it's a little bit more of advanced Ekahau in particular to reporting.
Yeah, and also I have... I have this sheet or a spreadsheet I use when I do validation assessment, and I put a lot of data in, and I want to see if I can maybe in the future write some scripts to move the information around, so I can actually take that information from the spreadsheet, move it to maybe the Ekahau project, and then when I generate my report, I have everything there. I'm not too sure. I'm still brainstorming on that and see how I can integrate that into my workflow, but it can save me a lot of time. Because like you said, I like to, add a lot of information. And that can save me a lot of time, especially if it's a high number of APs.
Okay. Oh, interesting.
So we'll see how it goes. I'm still, brainstorming on all of this. But yeah, so that's pretty much what I'll be working on. What about you?
I'll be doing some designs and then some working on making sure those implementations go well after the design. So a lot more meetings for me is what that means. And then not so nice for the meetings. I've been in way too many. But I want to go back to looking at Wi-Fi 6 again or 11AX because of the updated draft. I think the last time we looked at it, we were on draft 3. Yeah. There's now a draft 6. So I just want to see what all the differences are. Maybe we'll do a couple more episodes on that. And then I want to do more lab testing because I've been too much on the operational side lately. So just trying to reverse things, go back to a little bit more learning and playing around with different things and understanding how they work.
Awesome. Perfect timing. I can hear my daughter going down the stairs.
Well, guys, right. if you want to learn more about what we just talked about and check out all the links and frame captures, head over to cleartosend.net/206 where we have all that documented there. Check out the video as well by Mark Williams. And if you have anything else you want to add, just comment there on the show notes. We want to see what your thoughts are with whether or not you use 802.11k or maybe it's causing issues in your network. It's kind of good to see how it works in other people's environments. So there you have it. That's our show for this week, and we look forward to seeing you on the next episode. Thank you, guys.
Thank you. Have a good week. Bye-bye.